Welcome to the fifth and final video of Module 3 on exponential equations. In this video, we're going to be looking at fitting equations and determining if the application problem described is linear or exponential. We are asked to write an equation, exponential or linear, for each of the following questions, and then solve the related problem. Part says a patient is given 500 milligram dose of a prescription drug to relieve pain. After every hour, 20% of the medication is metabolized. How much active medication is present after 4 hours? Recall that in order to build an exponential function, we need to know that the problem involves percent change. And for a linear function, we're looking at the amount of change. What's being described here is a 20% metabolization of the medication for every hour. Therefore, it's actually an exponential decay problem. We're told that the initial value is 500 milligrams and that 20% decays. This tells us that 80% remains, and therefore our value of B is equal to 0.8. Notice 0.8 is the decimal representation of our percentage of 80%. Therefore, we have an equation that can express this problem. So A is equal to 500 times 0.8 to the power of t, where t is given in hours. So we've completed the first part of this problem, which was to determine an equation for the amount of drug present after a certain amount of time. Now, to solve the actual problem, we need to sub the value of t equals 4 to find how much is present after 4 hours. We find that after 4 hours, we have 204.8 milligrams. This can be rounded to approximately 205 milligrams, which is remaining after 4 hours. Question 2 says a baby is born weighing 2,100 grams. The baby puts on weight at a rate of 60 grams per week. How much does the baby weigh after 4 weeks? This problem describes a constant amount of change of 60 grams per week. Because the amount of change is constant, we can express this problem using a linear equation. We know that the weight of the baby is equal to mt plus b. So this is the general form of a linear equation, where b is the initial weight, and m would be your slope, or the amount of growth over time. We know that we initially have 2,100 grams. The constant growth is 60 grams per week. Therefore, we can write this equation as W is equal to 60 times T plus 2,100. Okay, to answer the actual question asked, we substitute a value of 4 into this equation to find the weight of the baby after 4 weeks. When we substitute the value of 4 in, we find that the weight is 2,340. Therefore, after 4 weeks, the baby weighs 2,340 grams. Problem 3 describes a baby is born weighing 2,100 grams. And the baby puts on weight at a rate of 3% per week. How much does the baby weigh after 4 weeks? This problem is very similar to the last one in that the baby's initial weight is equal. But in this problem, you can see that we have a percent change. Since the baby's weight is growing as a percentage, we know that this is an exponential problem and not linear. We know our initial weight is 2,100. We can express the equation for this problem. W is equal to 2,100, which is our initial weight, times 1.03 to the power of t. We get this value of 1.03 by considering that each month we have our initial weight and then we're adding 3%. So 100% of their weight the last month plus an extra 3% on top of that. And expressing that percentage as a decimal, we get 1.03. Now that we have an equation to relate the weight over time, we can calculate the baby's weight after 4 weeks by substituting a value of t is equal to 4. Now we evaluate W is equal to 2100 times 1.03 to the power of 4, which we find is equal to 2,363.56. Therefore, the baby weighs 2,364 grams after 4 weeks. So well done. Way to go, and make sure you try the practice problems that allow you to fit curves, both linear and exponential, to see how you understand this topic.